So about 2,000 years ago, the ancient Greeks were the first people to start thinking about what the smallest thing in the world is. Now, they knew things could be made smaller, but they were interested in what the smallest thing was. They would take rocks and they would break them in half. And when they broke them in half, they would break them in half again, and again and again and again, until it was broken into the smallest possible size. They then termed this undivisible, atomos. So the word atom comes from the Greek word undivisible. Fast forward now to the 1900s, two scientists were battling it out to try and understand the atom better. The first one is J.J. Thomson. He had come up with a model of the atom that we'll look at in a minute. The second scientist is Ernest Rutherford. He wanted to look about changing J.J. Thomson's model of the atom. J.J. Thomson said that the atom looked like this. It was a positive mass with small electrons floating around inside, and he called this the plum pudding model because it resembled a cake with currants in. Ernest Rutherford knew that J.J. Thomson was onto something, but he was convinced something wasn't quite right about this model of the atom. So he set about an experiment to change the way we think about the atom. He started by setting up his apparatus. This is a bird's eye view of the table below. Now Rutherford placed a piece of gold foil in the middle of the table. Now gold foil is made of atoms, like everything else in the world. You need to understand that it's made of atoms to be able to understand the experiment. Here is a picture taken on an electron microscope of gold foil. We can see the individual atoms in the gold foil. Now, Rutherford decided he wanted to fire something called alpha particles at the gold foil. Alpha particles are a helium nucleus. We can see here an alpha particle being emitted from a radioactive isotope. The alpha particle has 2 protons and 2 neutrons. Its overall charge is positive. Now he wanted to fire these through the gold foil. Now to detect them on the other side of the gold foil, he needed to place something called a detector. The detector was able to pick up the path of the alpha particles as they interacted with the gold foil and passed through it. Some of them went off at angles and some of them hit the detector right in the middle. Rutherford was able to move the detector around the table, and he was convinced that maybe he should put the detector around the front of the gold foil in case any of the alpha particles rebounded off the gold foil. His students he was working with weren't very happy about this because they saw it as a waste of time, but nevertheless they still did that. So he placed the detector around the front of the gold foil. Lo and behold, 1 in 8,000 alpha particles bounced off the gold foil. Now let's take a look at this practical with a more scientific drawing. So again, we're looking at it from a bird's eye view. We can see the thin piece of gold foil in the middle. We can see the vacuum vessel that everything was placed inside. We've got the radioactive source of alpha particles. Alpha particles were scattered at large angles. Most of them went through and were detected on the other side, but only 1 in 8,000 bounced back. What Rutherford had actually found out is he had discovered that there was a middle to the atom. Because 1 in 8,000 bounced back, it had to bounce off something. Now remember, alpha particles were positive. The middle of an atom is positive because it only contains protons and neutrons. So therefore, Rutherford had rewritten the model of the atom. It now had a middle to it. Nowadays we study atoms by colliding them together. This is a picture of the Large Hadron Collider. Scientists here fire particles around a big tunnel at the speed of light. They smash the particles into each other and break them apart. The model of the atom is always changing. And we can see here some of the evolutionary models the atom has gone through.